Welcome to this explainer. Today, we are diving deep into the Orbittest Studio user guide. This is essentially a survival manual specifically designed for QA engineers and test automation professionals who really just want to streamline their workflow. Listen, if you have ever felt completely bogged down by the absolute nightmare of maintaining remote device farms, configuring cloud accounts, or babysitting complex server infrastructure just to run a single mobile test, you're going to love this. Orbittest Studio completely removes that cloud hassle. It is a desktop application that lets you write, run, and review your automated Android tests all from one single window directly over a simple USB connection to a physical device. It's incredibly direct, highly efficient, and honestly a massive breath of fresh air for mobile testing. Okay, let's look at our roadmap for today. We'll be covering Section 1, Setup and USB Debugging, Section 2, Finding Elements with Inspector, Section 3, Packages and Templates, Section 4, Writing Reliable Scripts, and finally, Section 5, Troubleshooting. All right, let's jump right into Section 1, Setup and USB Debugging. We're going to completely remove the intimidation factor right off the bat. You really don't need heavy infrastructure to get off the ground here. Your minimums are super straightforward. You need Node.js version 20 or higher for the test runner, NPM, and any recent version of Android Studio or platform tools just to provide that Android debug bridge or ADB command. You'll also need an Android device running Android 8 or newer. But here is a critical tip, straight from the guide, and this will save you hours of frustration. Make absolutely sure you use a real data cable. Seriously, do not use one of those cheap gas station charge-only cables, or your device will literally just sit there charging while you pull your hair out trying to connect. Now, before connecting to the studio, you actually have to perform the classic Android secret handshake to authorize your device. You know the drill. Open your Android settings, tap About Phone, and tap that build number exactly 7 times to unlock developer mode. From that newly visible developer options menu, just toggle USB debugging to on. Once you plug the device into your machine, pay close attention to your phone screen. Make sure the phone is unlocked so you can physically tap Allow on the authorization prompt. Believe it or not, missing that prompt is a very common stumbling block. Moving right along to Section 2, Finding Elements with Inspector. Once you are connected and your device shows up as online, it's time to actually interact with the app. And the Live Inspector completely changes the game for QA engineers. You just open the device panel, click the Live tab to stream your screen, and open up the inspector. From there, you can click literally any UI element on the live video stream, like a login button or a text field, and Studio instantly highlights it in the UI tree, completely mapping out its unique identifier. You get the resource ID, the class, the text, and the bounds instantly. Just imagine the absolute relief of never having to parse through dense XML dumps ever again. You literally just point, click, and copy the ID directly into your test script. Now, when you're extracting properties from that inspector to use in your scripts, there is a strict priority list to make your tests totally brittle-proof. Always prioritize the resource ID. This is assigned by the developer and is without a doubt the most reliable way to target an element. If there happens to be no resource ID, you fall back to the visible text or the content desk, which is the accessibility label. Listen, using pixel bounds, the exact X and Y coordinates, is basically a ticking time bomb. Only use bounds as an absolute last resort, because the second that app runs on a different screen size or a slightly different layout, your test is going to break. Let's look at Section 3, Packages and Professional Templates. Because Orbittest is built right on top of Node.js, you have the entire NPM ecosystem right at your fingertips. And the best part? You don't even need to open a terminal. You can install NPM packages natively right inside the Studio interface. You just click the packages icon in the activity bar and search for whatever tool you need. Maybe you want Faker for generating some robust random test data, or maybe Axios for making HTTP requests to prep your backend. You just click install and then simply require it at the very top of your script. The built-in auto-completion picks it up automatically. To maintain consistency across your entire automation suite, the guide provides a professional test template that every single reliable script should follow. It's broken down into 4 strict phases. Phase 1 is Setup, where you cold start the app to a completely pristine state. Phase 2 is Navigate, where you wait for the specific screen you're testing to actually load. Phase 3 is Action, where you actually perform your inputs and interactions. And finally, Phase 4 is Assert, where you verify that what you expected to happen actually happened. Seriously, sticking strictly to this structure is going to save you hours of debugging later on. Which brings us nicely to Section 4, Writing Reliable Test Scripts. So let's talk about the single most important rule in mobile test automation, the golden rule of the cold start. State contamination is a massive headache for QA. If you run a test without resetting the app state, leftover login sessions or cache data from a previous run are going to silently ruin your current run. You absolutely must wipe the app data and cold start using 3 specific commands at the top of every single test. Stop the app, clear the app data, and then launch the app. This guarantees a pristine environment every single time. Another major cause of flaky tests? Timing. Mobile apps are totally asynchronous. Screens animate, data loads in the background. We've all hard-coded a 5-second sleep delay and then just sat there and watched our test randomly fail on a slow Monday morning. Avoid fixed sleep delays at all costs. Instead, you want to use dynamic waits, paired with realistic timeout durations mapped to actual app behavior. A simple navigation might only need 3 to 5 seconds, right? But if you are waiting for a network payload or for a loading spinner to disappear, give it 10 to 15 seconds. And finally, Section 5, Troubleshooting and Device Logs. Let's be real. Eventually, an app is going to crash, or a mysterious network error is going to occur. When that happens, the built-in Logcat tool is going to be your absolute best friend. It is designed for total simplicity. Android system logs are notoriously noisy, but here you just select your device, plug in your app's package name, and set the severity to info, warning, or error. This instantly filters out all that system noise so you can quickly diagnose the failure, trace the exception, and copy the exact logs right into your bug report. Beyond app crashes, you might occasionally run into physical connection drops or ADB issues. Think of this as your quick-fire survival guide. If your device suddenly shows as unauthorized, just unlock your phone screen and tap Allow on the prompt. If it shows offline or suddenly disappears entirely, you need to kill the server by running ADB kill server and then ADB start server right in your terminal. And if you see ADB command not found, well, you simply need to add your Android platform tools folder to your system path. So what does this all mean for you? Orbittest Studio essentially puts the power of an entire automation farm right on your desk over a single USB cable. It natively gives you all the tools you need, from isolating UI elements with a live inspector to generating robust test data with NPM packages, completely bypassing the usual cloud headaches. The roadmap is laid out for you. The only question left is how much time will you save debugging your first unbreakable test suite today? Thanks so much for joining me for this explainer, and happy automating.